Okay, so sorry for making you get these notes online, but because of the assembly, needed to make this up and through a YouTube video. Now be aware, I'm going to try to make them around 15 minutes each, so there might be 2 videos depending on how long it takes to present the material. So make sure you watch both if necessary. Okay, so we're going to talk about parallel lines and triangles, and this is a very big section because we learn 2 ideas about finding angles in triangles. Okay. The first thing, this idea of a parallel postulate, okay? It's sort of a theoretical thing. It says that through a point, not on a line, there is one and only one parallel line to the given line. So in this picture, you start with line L and point P. And you can draw one parallel line through point P, okay, to line L. Exactly one. Now, this parallel postulate is going to help us prove the next big theorem, and this is the big one. Triangle angle sum. You should start. You got to remember. Triangle angle sum theorem says that the sum of the measures, the sum, add, of the angles of a triangle is 180 degrees. So you see that picture, A, B, and C are the angles of the triangle. Add them together, you get 180 degrees. We're going to prove this triangle angle sum theorem in the next slide. Okay, so here is a picture, and we're going to prove the triangle angle sum theorem. So the proof sets up like this. Given triangle A, B, C, prove that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. Okay, and actually, I'm sorry. Instead of using A, B, and C, no, we're going to use A, B, and C. It's fine. Okay. All right, so let's do this proof. Statements here. And reasons. Give me 1 second. Let me make this red. Hold on. Make this red as well. Okay. All right. So statements and reasons. So first thing here is we're going to use that parallel postulate, 1. And we're going to create line L. L, parallel to segment AC. And this is going to be through the parallel postulate. This is what's going to help us do the proof. So I'm going to draw a dotted line. There's line L. And I'm going to create 2 angles. Angle 1 and angle 2. Okay? Alright, so now, angle addition postulate. Look up here. Angle or line L is a line, straight angle, 180 degrees. What 3 angles make up line L? 1, B, and 2. And again, I know there's multiple angles at B, but angle B is going to be this middle angle. So the measure of angle 1 plus the measure of angle B plus the measure of angle 2 equal 180 degrees. This could be angle addition postulate, it could be straight angle, I don't care. But we're going to use angle addition postulate. But now, look at what we have. Now I didn't mark this, but when we drew the parallel line, it was parallel to AC. I want to prove that measure of angle A plus B plus C is 180. Right now I have 1, B, and 2 is 180. So somehow I need to get rid of 1 and 2. Well, look up here. Look at angle 1. Angle 1 is right up here. It is, if I extend AC a little bit. Can you think about an angle relationship with angle A in the triangle and angle 1? Yes, they're alternate interior angles. Angle 1 is congruent to angle A. The same thing can happen over here with angle 2 and angle C in the triangle. That is because we created parallel lines, and these are alternate interior angles. And now the last step is easy. We just substitute. If 1 is congruent to A, put A there. If 2 is congruent to C, put C there. And we have what we want. The measure of angle A plus the measure of angle B plus measure of angle C equals 180 degrees. And that's just by a basic substitution. That's a nice little proof there. Okay? Nice little proof. I might make you prove that on the test. I'm not sure. So be ready for that. It's a very important theorem. We use it a lot. So be ready for this proof. Good. Alright, so let's try to do a problem here. It says, use the diagram. What is the value of z? Well, we're going to find x, y, and z. What are the values of x, y, and z? Okay, so we're going to find all three. So if I'm looking at this picture, okay, and I'm going to try to use colors here. Look at triangle ABD. Maybe what I'll do is just use triangle. Look at triangle ABD. It's this triangle right here, ABD. They give you 2 of the 3 angles. They give you 43. They give you 59. The third angle is x. We can find it by setting up the triangle angle sum theorem. Triangle angle sum. Triangle angle sum says that x plus 59 plus 43 should be 180. X plus 102 should be 180. Subtract 102. X should be 78. That's good. And now that we know x, look at where y is. Look at the relationship between x and y. They are linear pair. So we have a linear pair. So that means x plus y, or y plus 78, is going to be 180, because x was 78. That's all we did. We just took it based off the picture. Subtract 78. X is 102. I'm sorry, y. Y is 102. What am I doing? Y. Not x, y. And now I have y. And now finally z. To find z, now that I have y, let's use that smaller triangle. I'll do it in green. That would be triangle BDC, or BCD. Triangle BCD. This one right here. Z. So we're using triangle angle sum theorem again. Triangle angle sum. So I'm going to do z plus 49 plus y, which is 102, equals 180. That's z plus 151 equals 180. Subtract 151. And z is 29. And there's x, y, and z in this problem. Triangle angle sum theorem. Okay, next idea here. We have to talk about these two terms. Exterior angle of a polygon is formed by a side and an extension of an adjacent side. Formed by a side and an extension of an adjacent side. So notice down here, angle 1 is an exterior angle formed by this side, where 3 is on, and then the extension of the other side. So angle 1 is formed by this side and the extension of that side. There's angle 1, exterior angle. The other two angles, 2 and 3, the ones that are not adjacent, this angle right here is adjacent. These two are non-adjacent. And I guess say adjacent to angle 1, non-adjacent to angle 1. These two angles, 2 and 3, are called remote interior angles. They are the two non-adjacent interior angles. So again, it's just a little bit of a vocabulary, because we need to be able to identify these to use the triangle exterior angle theorem. Okay? The triangle exterior angle theorem says that the measure of the exterior angle is equal to the sum of its remote interior angles. So the exterior angle is equal to the sum of the remote interior angles, just like this. So in that picture, angle 1 is equal to 2 plus 3. We're going to prove this theorem together on the next slide. This one is not as important as the triangle angle sum, but still used. So here's the picture, and again the given is a triangle. Prove the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. Okay, so let's create our statements and reasons. So the first statement, okay, you have that triangle, so that's fine. What do we know? Well, because it's a triangle, I know that the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 is 180. This is the triangle angle sum theorem. I know that. I also know, just based off the picture, that angle 1 and angle 4 form a linear pair. They are supplementary. Now, because this has adding to 180, I'm going to do the same thing. Angle 1 plus angle 4 equal 180. That's a linear pair postulate. Linear pair postulate. And now look, if those three angles equal 180, right? 2, 3, and 4, and 1 and 4 equal 180, then we can do a substitution and say that the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 equals the measure of angle 1 plus the measure of angle 4. And this is by substitution because they both equal 180. So then lastly, if you look at the, I'm sorry, it's scrolled over, but if you look at the left side equal sign, 2, 3, and 4, the right side, 1 and 4, there is one thing that's the same on each side, 4. Cancel it out. Measure of angle 2 plus measure of angle 3 equals measure of angle 1. Canceling. And that's exactly what I wanted to prove. That those two remote interior angles equals the exterior angle. And we're done. Okay? So there we go. So believe that this works. Now I'll say that in problems, many of you will just use this relationship. You'll use this. You'll avoid the exterior angle theorem altogether and you just use that relationship. But I warn you that sometimes you can't. So be aware that you should try to use the exterior angle theorem and use this linear pair idea to check yourself. Okay? Alright. So let's do a problem. It says, two angles of a triangle measure 53 degrees. What is the measure of an exterior angle at each vertex of the triangle? Okay, well let's draw this picture. Two angles of a triangle measure 53 degrees. So let's draw a picture. Here's 53 degrees. There's 53 degrees. Now, let's extend each side to create 3 exterior angles. So the extension is going to be like this. I'm going to extend that side. So there's angle 1. I'm going to extend this side down here. There's angle 2. And I'm going to extend this side right there. There's angle 3. Okay. So what I want to do is I want to find the exterior angles at each vertex. Well, let's start with number 1. Angle 1, we don't know the angle measure right next to it, the adjacent angle. We could find that using the triangle angle sum, but I don't want to. I want to use this idea of the remote exterior angles. I'm sorry, the triangle exterior angle theorem. Triangle exterior angle theorem. Got to try to use it. If you don't use it, you never learn it. Which says that the measure of angle 1 is equal to the sum of its remote interior angles. 53 plus 53. The measure of angle 1 is 106 degrees. You could find that a different way, I understand. But, again, I want to avoid the triangle angle sum theorem for this, because you have to sometimes use the exterior angle theorem. So learn it. 2 and 3 are going to be the same. Linear pairs. The measure of angle 2 plus 53 is equal to 180. Subtract 53. The measure of angle 2 is 127 degrees. And that is also going to be the measure of angle 3 because they have the same interior angle. So the measure of angle 3 is 127 degrees. And there you go. So again, make sure you try to use the triangle exterior angle theorem in your homework. Alright. Okay, so here are your homework problems and the in-class problems. Because I'm not giving you time in class, you can do this and I'll give you credit for these as well. So I'll give you credit because the other class will have some time in class to work. So if you work on those in-class problems and bring them in, I'll give you credit for them. Homework is there, and we'll go over any question you might have. And also Interact Math is always bonus, so if you have trouble, go to Interact Math. Okay, thanks for watching, and we'll see you in class next day.